All right, welcome everybody. Today I'm going to talk a little bit about tube and tube testing. The best way to test a tube is with a tube tester because you can see that it is actually performing and transmitting the electrons like it should across the tube. But some of us don't have that, and I found a very simple test to at least ensure that you don't have shorts that are going to be something that might blow things up or make your amp go poorly, or simple test of the heater, etc. So if you put your multimeter on the continuity mode, which has this little, looks like a sound wave, because what that means is when you touch the your two probes together, it makes a noise, meaning that it detects the electricity is flowing. So for this use, I'm going to put a small alligator clip on one, just makes it easier for me to connect to the tubes. And what I want to show you then is, if you take, for example, this power tube, this is an EL34, you'll need to look up the data sheets, and we'll show the data sheets for each of these tubes. And then what that means is that you can then connect up to these in a way that will help you understand it. So you look and find the heater pins. Those two should always have continuity. And in most cases, no other pins should ever have continuity. Some power tubes do occasionally have the negative grid, which I think is grid 2, connected to cathode directly in the tube, and so it would just have one pin for that. So that's why you need to refer to the data sheet and see if there is something that should have continuity, but otherwise that's normally not the case. So if we look at this one, I'm going to connect to pin 7. And luckily, nicely on these are actually, if you look here, these are actually, you can see the pin number written on them, which makes it a little easier. But in this case, I want to connect to pin 7, and then I'm going to take my other probe and connect it to pin 2, and we should have continuity. And sure enough, we do. So that means it's good. You should also then test all of the other pins, because I should not have continuity on those. And then you can also go through kind of a daisy chaining process of testing all of the pins to make sure no other continuity happens except on those that are supposed to, like the heater pins, and make sure that none of them do it. Now I've done it the rest of this one, so I don't need to show it all to you. But here is the bigger problem with one that I had recently. This one, if I connect to pin 7, my heater wire, or heater connection, and then test some of the other ones, I have continuity on 2 like I'm supposed to. That's good. Let's check 3, which in this case happens to be the anode. Oh my, we have continuity. So the anode is what puts your high voltage, and that can be anywhere from a couple hundred, 250 to up to 500 volts, depending on the amp. Mine, it was a 500 voltage level rail that blew up all of the heaters on most of the other tubes and the several resistors in the amp. So it can be a good idea to test these out before we put them in. You think, well, I just got a brand new tube, it can't be wrong. You never know what shipment can do to a tube. It's all glass. It's all, very kind of fine instrument here, and it can actually be damaged just by shipment to your house. So at any rate, let's also look at a preamp tube as another example. This is a 12AX7, also an electroharmonics tube. And that tube has the pins for the heaters are on 9 and 4 and 5. So you could test any one of these 3, but all of them should have continuity. And as you can see, I've got it. But none of the other pins, if I kind of rub this across these quickly, have any continuity. I just bumped that a little bit, but so that's a good tube. Everything's looking good. Now you can also, I ended up having to test the other tubes. This one wasn't in the amp at the time. I think some of them, like I could get continuity for 5, but not for 4. Or in other cases, I couldn't get a continuity between any of them, because effectively it had gotten 500 volts. And if you look on the data sheet for these tubes also, it will tell you what the maximum voltage is that they're allowed to have. And most of the ones I've seen for related to these was either 100 or 200 volts is the maximum for the heater. So there you have it. We may cover a little bit more looking here for a minute afterwards about a data sheet and how to look this up, but that's the gist of how to test your tubes with a multimeter to ensure that you don't have any shorts that are bad, or to make sure that your heaters are working. Thanks.
All right, so now we're going to cover a little bit about the data sheets. Here is the EL34. As was mentioned, here's the pinout right around here. I've got a little thing that will pop up if you can look in the right corner. It looks like a sphere with these numbers on it. And in that, the pins 1 and 8 are normally, 1 is the third grid, and 8 is the cathode, and those are, the third grid is always linked to the cathode. In some tubes, that, as I mentioned, that will be linked together and off of a single pin. In this case, on mine, the amp I'm building, I'm jumpering those two together and then sending them off. Additionally, the filaments F are 2 and 7, and the most important thing, as I mentioned, is that maximum limiting values are listed here of all types. Generally, this UA, this is the anode maximum voltage of 800 volts. There is a maximum that it can, that it can basically, that is considered it can handle up to that for shorter periods of time. I think that's what the A0 is. But in normal operation, the maximum you should never do is above 800 volts. And then one of the more important ones is right here is the resistance, or sorry, the voltage of the cathode and filament together is 100 volts. That's the maximum it should ever take. And as I talked about, it took about 500, which is why they got cooked. It also is just good to know some of the general data about this. At some point, I'm going to do some videos that talk a little bit more about these graphs. Oh, my dog wants to get involved in this tonight. Okay. Thanks, Mallory. So then over here, we've got the ECC83, which is also the same thing as the 12AX7, which is another one I showed. The limiting values here, again, for the cathode is 180 volts, and we were up to, again, 500. So that cooked it pretty well. So the most important thing to note on this is, again, this is the filament here. It was, as I mentioned, 4, 5, and 9. So anode, it would be 1. So for some reason, there's a short between 1 and these on this type of a tube probably wouldn't be as big of a deal because it's 300 volts, and usually it can handle a little over on any design for a short period of time. But anyway, that would be it for me today. Well, it looks like Mallory wants to keep talking. Are you going to help us with the video today, Mallory? Okay. All right. Well, that will be it. Thanks.